Our third type of ionic compound is an ionic compound that contains something that's called a polyatomic ion. So we're going to learn how to name ionic compounds and write their formulas if they have polyatomic ions. Before we can move into the naming and the writing formulas, we have to learn what a polyatomic ion is. Now, a polyatomic ion is a charged molecule, so that's the ion part, that is composed of two or more nonmetals. So remember, the nonmetals are on this part of our periodic table, so those are our nonmetals. And it has two or more of the nonmetals covalently bonded. Now, we haven't talked about covalent bonding yet, that's what's coming up next. But these are units that are bonded together, and the unit as a whole is charged. That's a polyatomic ion. So poly being multiple, atomic meaning atom, so multiple atoms in one ion. So let's look at some examples of these. So one example would be hydroxide, which is OH, so it's an oxygen and a hydrogen bonded together. As a group, that OH has a -1 charge. Another example is nitrate, so one nitrogen and three oxygens arranged and bonded together. That group, that NO3 as a whole, has a -1 charge. So instead of oxygen having a -2 and nitrogen having a -3, you bond these nitrogens and oxygens together and you get something as a whole that has a -1 charge. SO4 is sulfate. Sulfate is one sulfur and four oxygens bonded together. As a group, that molecule has a -2 charge. Phosphate is one phosphorus, four oxygens bonded together. As a group, as a molecule, that group of atoms has a -3 charge. So we can treat these in the same way that we would treat any other nonmetal. Just instead of having phosphorus with a -3 charge, we have PO4, all of this with a -3 charge. Now, I'm not going to make you memorize them. I will give them to you. They're on the back of your periodic table. There's a whole list over here. And then there's one polyatomic ion that has a positive charge, ammonium, and it's over here on this side. But we have all of the polyatomic ions. What you have to do is be able to recognize the names, recognize the formulas as being polyatomic ions, so that you know when you go to write the names or the formulas, kind of what category that ionic compound is going to be in. So we need to recognize that hydroxide isn't an element. Hydroxide is a polyatomic ion, and we're going to find it on the back of our periodic table. So let's look at some examples. Like our two other categories of ionic compounds, they follow somewhat of the same rules. So we still have our positive charge first and then our negative charge. So here we have NH4 in parentheses and then a 2 and then sulfur. So NH4 we recognize, especially because it's in parentheses, as being a polyatomic ion. So if we look on the back of our periodic table, it's over here, it's ammonium. And it is NH4 plus 1. And then S is just sulfur. And we know that sulfur is going to be changed to sulfide. So we have ammonium sulfide, and the 2 goes back up here because our sulfur has a -2 charge. That's all there is to it. Like I said, it follows a lot of the similar rules as we have with our simple ionic compounds and our ionic compounds with transition metals. We're just swapping out the positive charges and the negative charges for polyatomic ions. Let's look at another example. CO is cobalt. Now, on the periodic table, you should be noting that cobalt is a transition metal. Since it's a transition metal, we need parentheses because we need to tell its charge. See how we're combining multiple rules into one type of name. So it's a transition metal, so it needs parentheses. Now our non-metal part is SO4, which we know is not an element. So if we go to the back of our periodic table, SO4 is down here, it's sulfate. And it's actually SO4, and it has a -2 charge. So we have cobalt, some charge here, and we just leave it as sulfate. If it's the polyatomic is the nonmetal part, we just leave it as its name. So this is just going to stay as sulfate. We're not going to change the end. If we change this to sulfide, we're indicating sulfur. So we have to leave it as sulfate because that tells us that it's SO4. Now, if we have one cobalt and one sulfate, and sulfate has a -2 charge, that means cobalt has to have a +2 charge. That way when we crisscross, they swap and will reduce down to COSO4. So we have to put a Roman numeral 2 in the parentheses. So we have cobalt 2 sulfate. Let's look at our last example. So this one looks very complicated. So we have Cu3PO4 in parentheses and then a 2. So Cu we know is copper. Let's just start there. And copper, if we find it on the periodic table, is right here. So it's a transition metal, which means we need a Roman numeral in parentheses. PO4 is definitely not a single element. It's a polyatomic ion. So if we go to the back of our list, it's all the way down here. It's phosphate. Just like sulfate, we're going to leave this as phosphate. If we change this to phosphide, we're back to phosphorus. We have to keep the 8 part on it to tell us that it's PO4. Now we have to figure out what number goes in here. So the first thing we can do is crisscross our charges and see where that gets us. So that would get us a copper with a +2 charge and PO4, our phosphate, with a -3 charge. Now, if we refer back to our periodic table, the back of it says that phosphate has a -3 charge, which is what we predicted. Therefore, copper must have the +2 charge. If we look at this the other way, if we have 3 coppers and 2 phosphates, phosphates have a -3 charge and we have 2 of them, we have a total of -6, which means if we have 3 coppers, each copper has to have a +2 charge. That way we have a total of 2 times 3 gets us a total of +6, and 2 times -3 gets us a total of -6, and our overall compound is neutral. So we're pulling all of the different rules together to write these names and formulas for polyatomic ions. The hardest part is going to be recognizing when you have a polyatomic ion, and that is just going to come with practice. If you feel like you want to memorize them just to give you some of that edge, just so that you recognize them, I would highly encourage you to go ahead and do that. So let's go the other way. Let's take the names and then write formulas for these ionic compounds with polyatomic ions. So the first one is iron 3 hydroxide. So iron is Fe. The Roman numeral tells us that our iron has a +3 charge. Now here's where it's going to get tricky. You have to recognize that hydroxide is not an element, that hydroxide is a polyatomic ion. Same with nitrate, same with acetate. You need to recognize that those aren't elements you're going to find on the front of your periodic table. They're polyatomic ions you're going to find on the back. So if we find hydroxide on the back of our periodic table, it's OH, and it has a -1 charge. Now, if we crisscross our charges, so our -1 comes down here, so it's just iron, and then our 3 is going to go out here. We have to treat hydroxide as one whole thing, so our 3 goes on the outside. We put parentheses around the polyatomic ion to show that it's one single unit. So we have Fe, and then in parentheses OH, and then the 3 on the outside. So that tells us we have 3 of our hydroxides, each with a -1 charge, so a total of -3. And then our iron has a +3 charge, and our overall compound is neutral. Let's look at our second example, ammonium nitrate. This one involves 2 polyatomic ions. Ammonium is NH4 + 1, found on the back of our periodic table. And nitrate is found on the back of our periodic table. It's over here. It's NO3 - 1. So when we write the formula for this one, it's just NH4 NO3. That's ammonium nitrate because we have one ion that has a positive charge. We have one ion that has a negative charge, so it's overall neutral. Let's look at our last example, strontium acetate. So strontium is an element. It's on our periodic table. It's over here. It's an alkaline earth metal. So it's Sr. Because it's not a transition metal, we know the charge on strontium. Strontium is a +2 charge because it's in the second column. It's right here. Now, acetate is a polyatomic ion. We find it on the back. It is right here. So it's C2H3O2, and it has a -1 charge. Now, when we crisscross our charges, we're going to end up with 1 strontium, because the 1 will go down there. The 2 will come out here. Remember, we have to put parentheses around our polyatomic ion. So we'll put parentheses C2H3O2, and then our 2 will go on the outside. So we have 2 acetates, each with a -1 charge, so we have a total of -2. And we have one strontium with a +2 charge, so we have +2, we have a -2, and we have an overall neutral compound. The additional reminder when we are talking about ionic compounds with polyatomic ions is that when we write the formulas, we have to put the polyatomic ion in parentheses. Because remember, it's polyatomic and it's an ion. So it's a molecule made up of many atoms that overall is charged. So we treat it as one unit. So we have to put parentheses around it when we're writing the formulas. Otherwise, polyatomic ions, we're pulling in all of our different rules from our different types of compounds. So are we going to find the charge for the metal on the periodic table, or are we going to find it because there's a Roman numeral? When we write the name, do we have to write a Roman numeral? Is it a transition metal? We need to pull all of those pieces together to write the names and formulas for our polyatomic ion ionic compounds.